What? What did I do wrong? Where did I get the negative 2? Oh, I subtracted 3x from both sides. So I took minus 3x, minus 3x, and then I divide both sides by negative 2. Okay, so if I had something like this, same sort of thing, right? If I have two logarithms, then whatever's inside the logarithms has to be equal. Now, you have to be careful with logarithms, though. Logarithms, remember, not every x is possible. If you look at the graph, remember, the graph of a basic one, negative values don't work. Well, negative values sometimes work if our graph is shifted around. So just because the answer is negative doesn't mean that it doesn't work. What we have to do though is we have to plug it back in and see if it will work. So what I have to do is I have to test this value. I said it was no solution because I planned it out. So with logarithms, you have to be careful. You have to actually test your solutions with logarithms. So whenever I do this, I get this, which looks like it should be okay, except for ln of negative 19 is impossible. I can't do that. So I have no solution. What? Try ln of negative 19 in your calculator, and it'll give you an error. So with exponents, we don't have to test those. Exponents will work. Logarithms don't always work. And again, if you look at your graph, it has to do with the graph. All x values work in an exponent. Not all x values work in a logarithm. Okay, anyway, those are simple ones. So let's make it a little bit harder. Okay, so when 3 to what power equals 5? I have no clue. So the way we solve it is, how do we get rid of an exponential? With a logarithm, right? Just like, how do we get rid of a square? We get rid of a square with a square root because they're opposites, right? We get rid of a plus with a minus because they're opposites. We get rid of a multiplication with a division because they're opposites. Well, the opposite of an exponential is a logarithm. So we get rid of an exponential with a logarithm. So, to get rid of this, what I'm going to do is I'm going to take the log base 3 of both sides. Now, what is log base 3 of 3x? It's x. Remember, we had that as one of our properties. If I have log base 3 of 3x, the log base 3 and the 3 cancel out, and all I get is x. So that's the point of doing that. I want those two things to cancel out. Just like a square and a square root cancel out. Now this, all I need to do is calculate this. Now if you have a fancy calculator, you just put that in your calculator. If you don't, how do you calculate that? With what? Yes. Other way around though. Use your change of base formula. Change of base formula says you take log 5 divided by log 3. Alright, so let's see. Log 5 divided by log 3. So I'm just going to round all my numbers off to 2 decimal places. So that's about 1.46. Okay, so unless you have something that works out nice and pretty, this is how you solve it. I have plenty of room there. Let's do the equivalent of that with the logarithm, just right next to that. So what's the opposite of a logarithm? An exponential. So what I'm going to do to get rid of that is I'm going to turn both of these numbers into exponents. Again, we had a property that said if the logarithm was part of an exponent, then they would cancel out. So on the left-hand side, what would that equal? These two things would cancel out, and I would just get x. And then 2 to the 5th is 32. Now, I should test that, but plugging 32 into that, that's not going to cause any problems, so I'm good. Okay, honestly, these are the two biggest concepts we have in this unit. As long as you get the concept of how to get rid of an exponential or how to get rid of a logarithm, you're good for the most part. So before I move this piece of paper and flip to the other side, any questions over those two things? Before I start making your problems a lot harder. Okay. Alright, so let's see what we have here. We'll start picking out some really good ones. All their problems are boring. Okay, so just like a square or square root, before we can get rid of it, we have to get it by itself. So before I can get rid of the exponential, I have to get it by itself. So I need to start off by moving the 5 and moving the 3. Okay, how do I get rid of an E? Okay, ln. So I need to do ln of both sides. Now what I'm going to do is I'm going to hold on to the ln, and I'm just going to wait and do all my calculations at once. It just helps reduce the error in my answer. So now I got rid of my e, so now I just solve it like a regular problem. So I'm going to subtract the 4. And divide by 2. Okay, so we can do one similar to that with a logarithm. Yeah, Taylor. Nope. Don't need to check it unless it's a logarithm. Okay, so I'd start by subtracting the 4 and dividing by 5. So if I subtract 4, I get 35. 35 divided by 5 is 7. Okay, then to get rid of a logarithm, I turn it into an exponent. Since this is base 7, I'm going to raise both of these and make them exponents of 7. Seven to the 7th is going to be a big number, so again, I'm going to hold on to it and just do all my calculations at the end, so I don't have to keep writing out this big, huge number over and over again. All right, so solve this. So I'm going to add 2 and divide by 3. So 7 to the 7th power plus 2 divided by 3. Now you should check that. So if I take that number, take it times 3, and subtract 2, and take the log of that, divided by the log of 7, I get 7. 5 times 7 plus 4 is 39. So the answer of that checked. All right, you good with that? So we can start the really fun ones? Well, fun one. I'm only going to do one of it, and then we'll be done, and I'll let you guys try them on your own. Alright, this one I'm going to take from the book, because if I try making this one up, half the time I mess these up. Making them up off my head really quickly. What example am I on? 7? Okay. Problem with that one is that there's two logarithms. That's not a huge issue if there were only two logarithms. Problem is that there's another number also. So, what you have to do with these is you have to get all the logarithms to one side. So, my first step is to add the logarithm to the other side. I wrote that a little small. Okay. I cannot do a problem with multiple logarithms. The only way to do the problem is with a single logarithm. How do I turn that into a single logarithm? Yeah, I condense it. I turn it into a multiplication. What is it? So addition turns into multiplication. So I can change this into this. So that's part of the reason why you learn condensing and expanding. The other part of it has to do with calculus, which is a ways away. Okay, so now I have a single logarithm, so now I can solve it like I have been doing. So if I have a logarithm, to get rid of a logarithm, I turn it into an exponent. Now, I just have a log here, so what's my base? 10. So I make both sides the exponent of 10. Okay, how do I solve that? Okay, I can divide everything by 5. Yep, I'm going to have to end up factoring. So two numbers and multiply to negative 20 and add to negative 1. I heard someone say negative 5 and 4. So that means my x values would be 5 and negative 4. Now, to test them out, you have to go back to your original equation. So let's see, x equals 5. I'd have log 25 equals 2 minus log of okay, everything seems to be fine. Let's see, I could actually double check this. 2 is the same thing as log of 100. Minus means division. So 100 divided by 4 is 25. So 5 checked. 4 doesn't, or negative 4 doesn't work right off the bat. I don't even care what this side is, because over here I get log negative 20, which does not work. I can't take a log of a negative number. So that negative 4 doesn't work. So I just have this. Okay, again, make sure that you go through these and all of these make sense to you, because a good portion of your test will be solving equations.